Alright, in this lesson we're going to look at stem and leaf plots. These are another way of displaying data, and sometimes they're a good alternative to a frequency distribution table because there's a stem and leaf plot over here which you can see it gives a kind of picture of the data. If you look at it sideways, it kind of looks like a bar graph. Here's the short first bar, and then there's two bigger bars and a slightly shorter bar at the end. So that's one thing, it gives you a picture, and also all the individual scores are retained. We can actually get all the individual scores from this data. Here's 3, here's 6, 12, 14, 15, and so on, without having to make any estimations. So that's going to help us when we're working out things like the mean and the standard deviation, where we need to know individual scores. Alright, let's have a close look at this stem and leaf plot. So on the left hand side we've got the stem. On the right hand side we've got the leaves, and each number is going to be made up of the numbers from the stem and then the final number from the leaf. This key here, which every stem and leaf plot should have, shows us how to interpret it. Okay, if we've got a 1 on the stem and a 4 for the leaf, then that's going to mean 14. So in this first row here we've got a 0 and a 3, so we could write that as 0, 3, but we don't put the zeros at the start of numbers like that, so that's just a 3. And we've got 0 and 6, which is just a 6. On the next row we've got 1 and 2, which means we've got 12. We've got a 1 and a 4, which means we've got 14, and so on. So on this row we've got all these numbers here. On the next row we've got these numbers. And then on the final row we've got these. So there we have it. This stem and leaf plot is just a shorthand way of representing this list of numbers. It just saves us a little bit of time, and it organises the data in a useful way, giving us this kind of sideways bar graph shape. Now let's look at a slightly different scenario. What I've done here is I've rewritten the stem and leaf plot, but I've changed the key. So this time you'll notice that the key says a stem of 1 and a leaf of 7 equals 1.7 meters. So I've changed what the key represents. So that means that now all these numbers represent, the stem and leaf plot represents a different set of numbers. Now it's going to represent 0.3, because the key tells me 0 and 3 represents 0.3 meters, and 0.6, and so on. This is going to be the list of numbers represented by this stem and leaf plot now, because the key is giving us a different interpretation. Another thing to remember about stem and leaf plots is that the leaves need to be in order. They need to be in numerical order from lowest to highest in each row. So in this stem and leaf plot that's already been done, but let's look at another one. Okay, in this stem and leaf plot there's a few things different again. This time we notice, first of all, we've got some stars as we go along the stem. We see that there's some numbers that have stars. When we look at the key, we find that there's two parts to the key now. In the first part we've got a stem of 2, and on the other side a leaf of 4, which means 2.4 kilos. And then down here it says 2 star, and 2 star for the stem and an 8 for the leaf is 2.8 kilos. And what that's about is that in this stem and leaf plot, it's going up in increments of 5. So if I want to have 2.3 or 2.4 or 2.0, then I'm going to put that in one row in this stem and leaf plot. But if I want to go above 2.4 to 2.5, 2.6, 2.7 to those numbers, I'm going to put it in this 2 star row. So this is for the leaves from 0 to 5, sorry, from 0 to 4, and this is for the leaf, this 2 star row is for all the leaves from 5 to 9. So you would use this arrangement when you've got more pieces of data and you want to break it down a little bit more precisely or a little bit further. So we're going up in increments of 5 instead of increments of 10 this time. That's what that's about. You may also have noticed that in this list the leaves are not in order. So they're not in order from lowest to highest. They're all jumbled up. Okay, when we have a stem and leaf plot, it might start off like that, but we're going to have to order it if it's going to make any sense and if it's going to be really useful. So this stem and leaf plot is in a stage where it needs to be reordered. So let's do that. So here we are. We've reordered the stem and leaf plot. So now all the leaves are in numerical order. And now we can write out the list of numbers that this stem and leaf plot represents, so we can see clearly what it's saying. And there's the list. So the first row is representing 0.1 and 0.3. Because we've broken it up into increments of 5 this time, this row would be all the numbers from 0.0 to 0.4. In the next row, we've got all the numbers from 0.5 to 0.9. That's what the 0 star represents. It's an increment of 5. So we've got 0.5, 0.7, 0.9, and so on. You can see how the list works. We say that for this data, we have a class size of 5. This is data with a class size of 5. Each row is an interval of 5. In our previous stem and leaf plot that we looked at, we had a class size of 10. Alright, well let's do something different this time. Let's start with a list of numbers and try and turn it into a stem and leaf plot. Okay, here's our list of numbers, and these numbers represent jelly beans in a series of large jars. Now, to put them into a stem and leaf plot, we're first going to need to create our line down the middle to separate the stems and the leaves. And then for this stem and leaf plot, we actually find that we've got 3 digits in our numbers. So we only want to have 1 digit for each leaf. So we're going to have 2 digits for the stems. Now if we look along the stems, we find that some numbers start with 54, some start with 55, some start with 56, and there's even some that start with 57. So those are going to be our four stems: 54, 55, 56, and 57. All of the numbers start with one of those 4 numbers. Okay, now we can start putting in the data into the leaves. So let's find all the numbers that start with 54. Here's one, 548, so I put an 8 here. There's another one here, 547, so I'm going to put a 7 there. Going through the list, there's a 543, there's a 545, so I can cross those ones out. They're done. Now we've moved on to the numbers in the list that start with 55, so we've found those 2. Here's another one, 559, 553, 552, and then we'll just do the rest of them. Okay, so there's all the leaves of the stem and leaf plot done, but this stem and leaf plot isn't quite finished yet. We're still missing a key with which other people will be able to interpret the data. We know what it means, but other people won't. And also we need to put these leaves in order. So let's do those 2 things. Okay, so that's been done over here now. We've got a key that tells us how to interpret the stem and leaf plot. If we've got 54 as the stem and 7 as the leaf, then that means we've got 547 jelly beans. And we've now put these leaves in order from smallest to largest. We've also tried to keep the leaves in nice neat columns. So you can see these 4 numbers are in a nice column, these are in columns. And that's important because otherwise, if they're not in columns, then we lose the meaningful shape of the stem and leaf plot. It's no longer relevant as a picture of the data. Okay, let's see how we can use a stem and leaf plot to find the interquartile range, which is a measure of the variability of the data. It's a measure of how much the data is spread out in one regard. Now hopefully you remember that the interquartile range is found by this equation, Q3 minus Q1. Now just a quick reminder about Q3 and Q1, what they mean. If we consider this orange block to be a set of data, so inside this orange block is a whole bunch of numbers. If we split the block into 4 quarters by finding the median of the data, which will be Q2, that's the median of the whole data, and then once we've split the data into 2 sections, we need to find the median of each of those 2 halves. So first, Q2 is the median of the whole data, and then Q1 will be the median of the lower half of the data, and Q3 will be the median of the upper half of the data. Okay, to find the median of a set of data, we use this equation. The median will be the n plus 1 over 2 place in the data. So n is the number of scores or number of pieces of data that we have. We find the number of pieces of data in this stem and leaf plot by just counting the leaves. And when we count the leaves up, we find that there's 18. N equals 18 for this data. So in our equation for the median, we're going to have 18 plus 1 divided by 2, which equals 19 divided by 2, which equals 9.5. So we're looking for the 9.5th place in the data. That's our median. Okay, so let's count along the leaves. Each leaf is a piece of data, so we've got to find the 9.5th place in the leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 0.5 will be in between these two pieces of these two leaves. So by finding the median here, we've split the data now into 2 halves, the lower half and the upper half above the median. To find Q1, we need to find the median of this lower half of the data. So we use our equation again, n plus 1 divided by 2. In this lower half of the stem and leaf plot, n is 9. There's 9 pieces of data below the median in the stem and leaf plot. So this time n equals 9 plus 1 divided by 2 equals 5. So this time we're looking for the 5th place in this lower half. When we count along, we find that the 5th place is this one here. So 551 is Q1. And since there's 9 pieces of data above the median, then we're also going to be looking for the 5th place. The equation will be the same, the place will be the same for the upper half of the data. So 1, 2, 3, 4, 5. This is the median of the upper half of the data. 567 is Q3. When we enter those values for Q3 and Q1 into the equation for the interquartile range, we come up with 16 jelly beans as the interquartile range. So that tells us that the middle half of the data from Q3 to Q1, that's 16 jelly beans from that point to that point. Tells us a little bit about how the data is spread out. One little point to keep in mind is that when you're finding the median, Q2, the median for the whole data, if the median falls in between 2 numbers, then that makes it easy to divide the data into 2 halves, because everything below the median, everything below that point will be the lower half, everything above it will be the upper half. If the median happens to fall on top of a number though, if Q2 is actually a number in the data, then when determining the upper and lower halves, that number is crossed out. So all the numbers below that number will be the lower half, and all the numbers above that number will be the upper half. The number itself won't be included in either. And finally, here's a summary of what we've learned in this lesson about stem and leaf plots. You can pause it and write it down if you like. Thanks for watching the video.